Hey everybody, welcome to the Chapter 4 review packet for geometry. It's covering these lessons in our textbook. Let's go right into it. 1 through 3, classifying each triangle as acute, obtuse, or right. If it's acute, that means it has 3 acute angles like this one does. So number 1 would be acute. Number 2, if it's a right angle, it's going to have a right triangle, it's going to have a right angle, a 90-degree angle. So this one is a right triangle. And then if it's obtuse, it's got at least, it can't have more than one actually, but it has an obtuse angle. So this one is obtuse because that is 107 degrees right here. So these two angles made this one obtuse, this one right respectively. There's 3 acute angles. That makes that first one acute. Numbers 4 through 6, classifying each triangle as scalene, isosceles, or equilateral. Scalene has no equal sides, and that's like this one, number 5. So why am I writing isosceles? I don't know. This should be scalene. So scalene right there. Equilateral, it looks like this one's equilateral. All 3 sides are congruent. This one is also isosceles because, at least by the definition in our book, an isosceles triangle has at least 2 congruent angles, but equilateral is the better classification. If they're all the same, equilateral, and then right here, this one and this one are congruent, so that means this one is isosceles. That's the best classification, and in this case, the only classification for that one. Number 7, find x and the measure of each side of equilateral triangle. So that's pretty important on this one, FGH. Let me draw an equilateral triangle. At least draw a good sketch of one. So this looks pretty close to being an equilateral triangle to me, and we will assume that it is the case. Put all 3 of those sides being congruent. FGH. FG is x plus 5. GH 3x minus 9, and FH 2x minus 2. And we're trying to find the measure of each side. So if they're all the same, we can set them equal to each other. So I could say that x plus 5 would equal 2x minus 2. I could start by saying that. Subtract x from both sides, add 2 to both sides, and you've got that x equals 7. That's pretty important. It doesn't tell us what the lengths of each side are, but it does give us one piece of information that we're supposed to find. So we're supposed to find x and then find FG, GH, and FH. So if FG is x plus 5, that means FG would be 7 plus 2, which is 9. So that's part of our answer. This was part of our answer. FG is 9. Show the work for all these, but it's pretty quick work to show. So this is 3 times 7 minus 9. That would be 21 minus 9. And I just noticed a mistake I made there, so I caught myself there. This is x plus 5, not x plus 2. So 7 plus 5 is 12. So this should be 12. 21 minus 9, that makes more sense then. This is also 12 because they're all equilateral. They would have to match up. So GH is 12, and then 2x minus 2 for FH. This would be 2 times 7 minus 2. That's 14 minus 2, which does also equal 12. So that all checks out. Number 8. This one says triangle Lmn is isosceles, with LM being congruent to LN. So L is the vertex angle if that's the case. This may or may not be how the triangle actually looks. This might be longer than these 2 sides, but I'm just going to say that that's the case. We'll assume that this is not necessarily to scale, but LM is the same as LN, so I've marked that in the picture like that. LM, B, so we're looking for B. What does B equal? What does LM equal? LN and MN if I'm given these lengths of the sides. So LM is 3b minus 2. MN is 5b minus 2. And LN is 2b plus 1. If I know these two are congruent, I know these two expressions must be equal to each other. So 3b minus 2 must equal 2b plus 1. Add 2 to both sides. Subtract 2b from both sides. And you've got b by itself. This canceled, equals 3. And then if b equals 3, we can find the rest of these now. We can find that Ln would be 2 times 3 plus 1, and that is 6 plus 1, which is 7. We know that Lm would be 3 times 3 minus 2, 9 minus 2 in other words, also 7, which we expected. That should be the case if we did it right, so they're isosceles. Those two are congruent, and Nm is going to be 5 times 3 minus 2. So this actually ended up being the longer side. So if this were an accurate picture, these two sides should have been shorter than this side. That's why we don't necessarily trust the picture, we trust the information in the picture. So this is 7, this is 7, and Mn or Nm is 13. Number 9 through 11, find the measures of the angles that we see here, here, and here. So we're referring to this figure below. I know that 1 would be these two added together, subtracted from 180. That's going to be 125 in there, and 125 subtracted from 180 would be 55 degrees. So that's 55 degrees for the measure of angle 1. By vertical angles, this would have to be the same thing then. So the measure of angle 2 is also 55 degrees. And then the measure of angle 3 would be 180 minus, this is 55, this is also 55. So minus 55 plus 55, that's going to be 110. 180 subtracted from, or 110 subtracted from 180 is 70 degrees. Moving on to 12 through 14, referring to the figure, find the measure of angle 1. A couple ways we could tackle this one. We could find this one first, and then do 180 minus whatever that is to get you that one, being triangle sum theorem and linear pair. But we could do something easier. Exterior angles theorem says that 1 has to be the sum of the two remote interior angles. The interior angles, in other words, not right next to angle 1. So we could say that 1 is 70 plus 55, which is 125. So that's the measure of angle 1 right here, 125 degrees. The measure of angle 2, that's another vertical angle, so that would have to be 55 degrees in the picture, right here and right here. So the measure of angle 2 is 55 degrees. And the measure of angle 3, we could use exterior angles once again, say that the measure of angle 2 plus the measure of angle 3 would have to equal this one and this one, our remote interior angles with respect to this exterior angle. Since I know what 2 is, 55, I can easily figure out the measure of angle 3 from there, subtract 55 from both sides, and I've got 95 degrees for the measure of angle 3. Moving on to number 15 and 16. Identify the congruent triangles in the figure. We want to label them in a matching way. It looks like we're told that they are congruent, so we can just look at the sides there. We've got 1 mark and 2 marks and no marks. I could go B to A to C and do that is the same way as R to D to S. So that's one valid way to say this, that BAC is congruent to triangle RDS. You could also say ABC, go in alphabetical order. That would be DRS in a matching up way. ABC and doctors. There's other ways to rearrange these letters. Just as long as B matches up with R, A with D, and C with S, you are good to go. And then down here, again, look at the number of markings that are there. That's, I think, the easiest way to match up the letters. I'm going to go from 1 mark to 2 marks to 3 marks. Connect them in that order. So that's L to M to N. That would match up in the same way over here as Q to P to R. That's 1 to 2 to 3. So Q, P, and R would match up in a corresponding way. Number 17, name the congruent angles and sides for the following pair of congruent triangles. You've got 3 angles and 3 sides that would have to match up. R would have to be congruent to L, the first to the first, the second to the second, S to M, in other words, and the third to the third, so T to N. And for the sides, you would have to have the first two matching up with the first two over there, so RS is congruent to LM. You got ST is congruent to MN. And you have RT is congruent to, that's the first and last letter, congruent to the first and last letter here, LN. So that's the congruent angles and sides. That's all 6 of them. We're good to go and move on to number 18. So find the measures of the sides of triangle KPL and classify the triangle by its sides. So to do this, best way to do that is to either use the distance formula or to draw a grid. So I'm going to include a grid here. I'll make those a little lighter so it's easier to see. And 1 second here, I'm going to have to erase some of this. Okay, so good to go now. I've got more of the grid showing up. Looks like 5 is the biggest I go in any direction, so as long as I went at least 5 in every direction, I'll be good to go with that. It's definitely at least 5 if I go about it like this. Continue with my axes using the black for those, and now I'm going to label my points using blue. 5, -3, 1, 2, 3, 4, 5, and down 1, 2, 3. There's a point right there. 3, 4 is right here. This is K at 5, -3. This was P at 3, 4. And -1, 1 would be right here. That's L at -1, 1. And it's a triangle. KPL is a triangle, so I'll connect those. And I'll stay consistent with the blue there. So to me it looks like this might be isosceles. Might have this side and this side being the same. Let's see if that's actually the case. So on each one of these, if you use the distance formula, that's fine. It might have been actually faster since we didn't have a graph already to do that, but I think some of you are more comfortable with doing something like this. So forming right triangles on the sides of each leg, or of each side of the blue triangle, and figuring out how long each one of those are. So using Pythagorean theorem to figure out what's the hypotenuse here, what's the hypotenuse here, what's the hypotenuse there. This one is going up from 1 to 4 there, so that's 3. That's a 3 by, and then -1 to 3, that's a 3 by 4 right triangle. This one's a 2 by 1, 2, 3, 4, 5, 6, 7, going down from 4 to -3. So that's a 2 by 7 right triangle. This one is a 4 by 1, 2, 3, 4, 5, 6. So 4 by 6 right triangle there. So for each one of these, I can use the Pythagorean theorem. I've got LP squared would equal 3 squared plus 4 squared. That would be 9 plus 16, which is 25. So that means LP is a square root of 25, or that just equals 5. We always want to simplify that if we can. For KP, KP squared would be 2 squared plus 7 squared. That's the square root of, after you add these together, 4 plus 49, that's 53. So the square root of 53 is KP. And then I'll show what KL is up here. So KL squared would equal 4 squared plus 6 squared. That'd be 16 plus 36. That would be 52. The square root of 52. You could take out, this is 4 times the square root of 13, so you could take out the 4 as a 2. The square root of 4 is 2. So that would also be the same thing there. So that's fully simplified, simplified radical form for all 3 of those. KP is a square root of 53. PL is 5, and LK is 2 times the square root of 13. The classification, since none of these are actually the same, this one and this one are very close, but they're not actually the same length, so we could say that this is classified as a scalene triangle by its sides. We're not told to classify it by the angles, but it looks like it would be acute if we had to do it by the angles as well. Number 19 through 21, determine which reason can be used to prove the triangles are congruent. It's not possible to determine they are congruent, right? Not possible. On this one, if I had some parallel lines, then I could prove angles here and here would be congruent to angles here and here. I don't, though. If I knew this was the midpoint, I could prove this side and this side are congruent, this one and this one, but I don't have that either. You have to have at least 3 parts matching up in the triangles to say they're congruent. So this one is actually not possible. On this one, you have a right angle right here. That means you could also say that this one is a right angle right here. You've got a linear pair. So there's a couple different things you could use for this one. You've got side, side, side matching up with side, side, side here. So side, side, side is one possibility. I would also accept side, angle, side. If you said angle, side, side, or side, side, angle, that is not a theorem that actually works. So you couldn't say that, but you could say one of those two things. And then on this one, it looks like we have 2 sides matching up with 2 sides here. This side is shared by the reflexive property. This is not one where we have to use a 2-column proof format or a proof format to do this. We can just mark up the picture and then say which one would make them congruent. So we had 4 possibilities. Remember, you've got side, 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 you've got side, angle, side, you've got angle, side, angle, and you have angle, angle, side. If you say side, side, angle, you are wrong because you are making a donkey out of yourself. If you spell that backwards, think about that. Okay, yep, that's not a theorem. You can prove why that doesn't work with a counterexample. But side, 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 that is a possible thing to say here. There's nothing in the picture that would prove congruent angles, so I can only say that on this one. 22 through 24, we're using this picture. We're given that Fkg and Kjg, excuse me, and Jgh are all isosceles triangles. It looks like Fkg, that's already marked. Kgjj, that's also already marked here. And Jgh also marked there. Measure of angle Kgh is 51. We're told that this angle then, Kgh, connect them there from here to here. The whole thing is 51 degrees. So we can use that given information to figure out some of these other angles. What's the measure of angle Kfg? Well, if this one's 21, I'll go with green on this one. So this one's 22, excuse me, this one's 22 as well then, because it's an isosceles triangle. Those base angles have to match up. Kfg would be 180 minus those two added together. That's 180 minus 44, which is 136. So this is the measure of Kfg. That would have to be 136 degrees. For Kgjj, Kgjj is this one right here. So if this is isosceles, once again, you've got 2 base angles that would be congruent. So that means this one is also 82, and that means the red one would have to be 180 minus 82 plus 82. That's 180 minus 164. That means you have 16 degrees left over right here. This is going to be 16 degrees for Kgjj. And then finally I'll go with purple. On this one, what's the measure of Jhg? Jhg is this angle right here. I know that this one and this one are congruent. Another isosceles triangle. I know that this one right here, Jgh, would have to be 51 minus 16. And 51 minus 16, that's 35 degrees right there. So if that one's 35, this one's also 35. That means you have 180 minus 35 plus 35 left over for that one. That's 180 minus 70, which is 110 degrees. So the measure of JHG is 110 degrees. So I could put that in the picture if I wanted to. Moving on to 25, says that triangle RSU is an equilateral triangle. RSU is the big one. So this one, and this one, all three sides are congruent then. It also says RT bisects US. So that means this segment is cutting US in half. This segment right here is congruent to this segment right here, in other words. So if this is 5x, this is also going to be 5x over there. That means the whole thing is 10x, which is going to be very useful in this problem. So find x and y. So if I know this side is congruent to this side, I can say that 8x plus 1 equals 10x. I could subtract 8x from both sides, and I'd have 2x equals 1. If I divide both sides by 2, I get a fraction on this one, but that happens sometimes. X equals 1/2 if that's the case. And if I know that this is an equilateral triangle, I know that all these angles in the corners or in the near the vertices of these angles of the equilateral triangle, I know that whole thing right up here would have to be 60. All the degrees are 60, and that means that you have excuse me, you have by side angle side two congruent triangles here, RUT, triangle RUT, and triangle RST. So that means all these corresponding parts would have to match up as well. That means we could say that this angle right here is the same as this angle right here. And if that's the case, the whole thing is 60, that means this angle is 30 degrees. And so you could say that y minus 2 would have to equal 30. And if you add 2 to both sides, you've got y would equal 32. Number 27 and 26, 26 and 27. We're trying to find the missing coordinates. If this is r at 0, 0, and this is s at 2a, 0, and this side right here is congruent to this side right here, that means this length from here to here is from 0 to 2a, that's 2a, and that makes this the same from here to here as well. So this is all stuff we need to know to be able to figure out what that is. That means t is at, that's a perpendicular angle or a right angle right there. It means it has to go straight up. It's horizontal here, so this is vertical here. That means the x value stays the same. It's still at 2a, but it went up by 2a from 0, so that would also have to be 2a for the y coordinate. That's t at 2a, 2a. And for over here, if this is 1/3 b and 0, this marking, I'm not real happy how that turned out here, but I think what they're trying to say is that with that little mark there, that this whole side here, whole side here, and whole side here, this is all an equilateral triangle. That means you'd have 60, 60, and that we're cutting this in half. So this mark, or this point up here, would be for the x coordinate, it would be half of that. So we have 1/2 of 1/3 times b. That would be, it's a pretty ugly b, just a second. So 1/2 of 1/3 times b, 1 times 1 is 1, 2 times 3 is 6. So this is 1/6 b, would be the x coordinate right here. And so that means s is at 1/6 of the value of b, and then you don't really know how much higher that is. There's no information on the picture to tell you what that variable would have to be, so you could pick your choice of variables on that one. I'll just say that that is at some coordinate a up there. And so let's move on from there for 28 through 31, finishing up this with writing some two-column proofs. So given that x is the midpoint of AB and CD, we're trying to prove that CA is congruent to BA. So let's write down that x is the midpoint, first of all, of AB, and CD. That is given to us, so that's our first reason. Step 2, if it is the midpoint, we could say that this and this are congruent. We could also say that this and this are congruent. So I'll say that AX is congruent to BX, and also that CX is congruent to DX. All those things are true by the definition of the midpoint. And then step 3, I don't have 3 parts yet that match from here to here, but I could prove that that's true, that this angle and this angle are going to be congruent. That's AX, angle AXC would be congruent in a matching way to BXD by, that would be vertical angles right there. So you could say vertical angles theorem, definition of vertical angles, just vertical angles. I'll take any of those as your teacher. If I'm your teacher, those are all good for me. And then so that would be side angle side right here, matching up with a side angle and side. The angle is included in between the two sides, and so we could prove that triangle AXC is congruent to triangle BXD by side angle side. That doesn't prove what we're trying to prove in the end. We're trying to prove this is true in the end, but now we are there. And so based on what was in the picture originally, I actually couldn't label anything, but to be consistent with how I had done stuff in class, I could add all this extra red stuff in the picture as we went along. Now I can prove that the two sides here and here would have to be matching up or congruent because they're corresponding parts of triangles that we just proved were congruent. So that would be corresponding parts of congruent triangles are congruent. That, or CPOC-TAC, works to prove that CA is congruent to BA. CPOC-TAC just being the same thing with of and thrown in there. Corresponding parts of congruent triangles are congruent, not and, excuse me. But that's what CPTC stands for. So we got that one. Let's move on to 29. And I'll mark up my picture in blue. I'll try to be a little more consistent with that one here, and use red to prove extra things as I go along. So this is true and this is true on this one. 29. Whoops. This is just step 1. It's not step 29. Don't worry, I'm not going to make you do a 29-step proof in this class, at least. This is given information. And step 2, looks like I'm going to go to red like I had said, but blue information is given to us. So angle F, this one is congruent to angle M. FL is parallel to PM. So in red, based on what's there, I could also say that this side, it's shared between those two triangles. I'm trying to prove that MPL is congruent to FLP. And so that's a shared part of those two triangles. I could clearly then say that LP is congruent to itself, LP, by the reflexive property. So step 3, I've got one side and I've got one angle, but I do have enough to also prove that this angle would have to be congruent to this angle. Notice you have parallel lines, and these are alternate interior angles with respect to those parallel lines, and this transversal. So you have angle 1 is congruent to angle 2 by alternate interior angles. And that means you can prove what you're trying to prove was true. We can now prove that triangle MLP would be congruent to triangle FLP by, it looks like we have angle, angle, and a non-included side matching up with an angle and a non-included side. So angle, angle side, and not angle side. Angle is what works there. Number 30, we're given that BD bisects AC and that AB is congruent to BC. So directly from what's given, that's really the only thing I could mark up in the picture Definitely can use this to mark up something in a following step though. So let's write down what's given. BD bisects AC, that AB is congruent to BC. Both those things are given to us. And then in step 2, if this is true, if BD bisects AC, that means that this side here, or that length there, would be the same as that length there. We could say in words then that AD, or in symbols, AD is congruent to CD by the definition of a bisector. So if it bisects, they have to be congruent. And it looks like we could also prove that that side being shared in both triangles would have to be congruent to itself. So BD is congruent to BD by side, side, side. And it looks like ABD, why am I saying side, side, side? I'm getting ahead of myself here. I'm getting excited. This is the reflexive property. Sorry about that. Side, side, side is what I can use to prove that the triangles now themselves are congruent. So triangle ABD is congruent to triangle CBD. ABD here, CBD there, by side, side, side. And finally, number 31, triangle RTS, it looks like it might be congruent to triangle RZS, so it looks like that's the route I'm going to take on this one. But let's see what we're given. We're given that RS bisects angle TRZ, so it bisects an angle instead of a side on this one, and that angle STR is congruent to triangle or angle SZR. These are both given. So based on that second bit of information, STR would be this angle and SZR would be this angle. I can mark up the picture like that. Based on the fact that it bisects this angle, RS bisects angle TRZ, I could add this in the picture. And then that would allow me to say in symbols that angle TRS is congruent to angle ZRS by the definition of an angle bisector. So that segment cut the angle in half by what it said right here. So we can say that's the case. And then we've got an angle and an angle. I've got nothing else that could prove this angle and this one are congruent, but I do have in the picture RS being shared by both triangles. So I could make that mark and say that RS is congruent to itself in the picture by the reflexive property. Trying to prove that the matching up segments here, ST and SZ, are congruent. I've got enough to prove that the triangles are congruent now. Triangle, looks like STR is one way I could say that. Triangle STR is congruent to triangle SZR by, this is an angle, and a not included side in both triangles. So angle, angle, side is what works there. And that finally tells me that what I'm trying to prove in the first place is true. ST is congruent to SZ because those are corresponding parts of congruent triangles that are congruent. So CP-CTC or CPOC-TAC works for that. Whew! Made it. Alright, so that is all 31 questions. Go back and review as needed. If you saw any mistakes in there, please comment, and I'm happy if you're one of my students to give you some Wagner bucks, some bonus bucks for that, for helping me out to make these videos better. But go back, review as needed, and hope you study hard and do well on your next test. Have a great day, and I'll see you later when you come and watch another YouTube video.